Hi everyone and welcome to the new video. If you are at least a bit interested in radiation, you definitely heard about the Radiacode. It is one of the most popular radiation detectors today. But which model should you choose and do you really need one? In this video I will compare three latest Radiacode devices, Radiacode 110, Radiacode 103G and the newest Radiacode 0. And I will also explain my experience of using Radiacode for about a year. I will explain pros and cons of Radiacode devices, and I will also test them with different radiation sources. Before we begin, a small legal disclaimer. And now, without further ado, let's get into it. As a first step, I will show my experience of using the Radiacode for about a year, and I will explain its pros and cons. As a spoiler alert, I like Radiacode, it's a great device. And this video is not sponsored, I bought this new Radiacode on my own. It's really compact, it's powerful, it has a perfect battery life. I actually forget when I charged it last time, I think maybe 2 months ago. With such a small size you can easily take the Radiacode to a hike or to a flea market. I also take it with me on a vacation. For example, if you see an old vintage clock on the flea market, you can easily check if it's radioactive or not. And the detector is compact, it doesn't attract too much attention. It's not stupidly big like some old devices as Gamma Scout. Radiacode also has a connectivity with an app, and there are lots of interesting features there. You can plot the radiation on the map. With the scintillation detector, you not only can see that the object is radioactive, but you can also see why it is radioactive. You can see which components of the decay chain are there, so you can identify the components, which is fun. I will show later in this video how it works. So as you can guess, I like Radiacode, but it has some disadvantages as well, and I will show it. And the most important, it is mostly a gamma detector. It is not really sensitive to alpha and beta. As we know, there are three types of radiation, alpha, beta and gamma. Alpha is a helium nuclei. They have a big energy but a small penetrating power, and they even can be blocked with a piece of paper. How does it practically works? As an example, here I have an americium source and it is mostly an alpha emitter. And here I have a GMC radiation detector. It is sensitive to alpha and beta and gamma. And when I put it nearby, we can see that the level is really high. How do I know that there is a lot of alpha here? It is easy, I can cover the source with a sheet of paper, and as we can see, the level is much lower. And obviously Radiacode is not sensitive to alpha, because alpha particles cannot penetrate its plastic case. I can put the Radiacode nearby. As we can see, it can detect some radiation, but the level is really lower. And by the way, for this comparison, I switched Radiacode to the CPS mode, which means counts per second. In this mode, Radiacode is calculating the number of particles, so it is easier to compare. Is the lack of alpha sensitivity practically a problem? Technically not, it's just physics. If you want an alpha detector, you need a special detector with a very thin window like this GMC. Radiacode is just not designed for that. It's nothing bad, but you should be aware about this limitation. And the second thing I want to show is beta radiation. Beta radiation is mostly a stream of the high-speed electrons. Beta radiation has a better penetrating power, it can go through the paper, but it can be stopped by the piece of the aluminum. And as an example, here I have a small pot made from the uranium glass. Again, I can use my GMC detector, and as we can see, the radiation level is pretty high. Uranium glass emits both beta and gamma, and how can I know that there is a beta? I can cover the object with a sheet of the aluminum. And as we can see, the level is much lower. And now I can take the Radiacode. And as we can see, the radiation level is increasing, but really not that much. You must watch carefully, or you must set the alarm threshold to low if you want to detect a uranium glass like this. Is it practically a problem? Well, for me it is not. You can easily detect uranium glass with a UV light, and you even don't need a radiation detector for that. Radiacode is not really sensitive to beta, but it still can show that the object is radioactive. And even more, with the gamma spectroscopy it can show why the object is radioactive. For example, you can figure out that this is a uranium glass and not a thorium glass. I think it's really cool, and the Geiger counter cannot do this. So technically these two detectors, GMC and Radiacode, they complement each other, and it's nice to use both. And now I will show the gamma radiation, the area in which Radiacode really shines. And here I have a vintage clock. It is radioactive because it has a radium paint. This technology was popular from the 1920s up to 1960s. The mix of the radium and the zinc oxide was glowing in the dark, which was cool at the time. Because of the radium, this clock is radioactive and it mostly emits gamma. And as we can see, we can easily detect it with the Radiacode. And for this kind of source, Radiacode works really well. It's highly sensitive, you can easily detect the object, you can see the radiation level, you can enable particle clicks, you can enable alarms and so on. And much more features are available in the app. For example, you can record the radiation log. I was using it in the airplane and it was fun to see the increase of the radiation level during the flight because of the cosmic rays. I think most of people are not aware of that. So this was the brief introduction to the Radiacode and its pros and cons. And now let's see the comparison of the real Radiacode devices. And as a first step, let's open the Radiacode website and see which models are available. And as we can see, in total there are 5 of them. Radiacode 110 is the first one, and as we can see it has the better sensitivity. We have 77 counts per second for the 1 microsievert per hour. And the higher the sensitivity, the easier to spot the radioactive source. And in my opinion, it is one of the most important parameters. At least it makes the device much more convenient to use. For example, if a cheap Geiger counter has only 20 counts per minute, then you need to wait 1-2 minutes to see a reliable reading. Practically you will detect the radiation as well, but you must wait too long. With a really sensitive device, you can see the increase of the radiation practically in real time, within 1-2 seconds, which is really nice. I will compare the sensitivity later, but now let's see other devices. The second one is the Radiacode 103. It's the model created 1 or 2 years ago at the time of making this video. The third model is 103G. As mentioned in the website, it has the better spectral sensitivity, so you can collect the spectrum with a better accuracy, and I will show it later. Here we also have a Radiacode 102 model, which is practically the old one. I think it was released about 3 years ago. Still, as we can see, it is not that bad. Its sensitivity is the same as for 103. It still has a bit worse spectral sensitivity, but I think it still will be able to detect the radioactive source. So if your budget is strictly limited, it's still a good choice. And we also have the newest model called Radiacode 0, which is the latest one. And as we can see, it is marketed as a new one from 2026. And because it's the newest, let's start the comparison with this one. Okay, let's start with the Radiacode 0. This is the page on the official Radiacode website. And what we immediately can see, it has a scintillation detector from the organic plastic, which is not suitable for spectroscopy, so you will not be able to get the gamma spectrum and to analyze why the object is radioactive. Also, it has a lower sensitivity, as I mentioned before. In the description we can see that this is the newest model, and this is revolutionary, but in my personal opinion it's a very niche product and you need to think twice if you want it or not, and I will explain why. We can click for the page to see more details. And the general idea of this Radiacode that it was specially designed for the extreme conditions. What does it practically means? This Radiacode can get really high radiation doses. As mentioned here, 9000 millisievert, which, let's be honest, is practically unrealistic for most of scenarios. Even from this picture we can get the idea that, for example, a normal radioactive clock has only the range of 5 microsieverts, and we practically don't need a range of 9 million microsieverts. It's just an unrealistic range for most of cases. Personally, I don't have this device because I don't see a reason to buy it. It was designed for use cases like a radiological incident or something like this. And unless you are preparing a trip to the Chernobyl reactor core, or unless you are preparing to the nuclear war, You practically don't need this range. It's an interesting product, and in some cases it's indeed revolutionary, but it's just not really suitable for the everyday use in my opinion, and I can show you why. And now I can do a simple experiment. This is a healing pendant from China. It has a thorium glass and it is slightly radioactive. And as we can see, the radiation level is between 1 to 2 microsieverts per hour. And this is the typical vintage watch. Which has a radiation level of about 2 microsieverts. And this is the Jazz clock made in France. It has a bigger amount of radium, but still its radiation level is less than 10 microsieverts. And this is the most radioactive object I have. This is the Martian compass made in World War I. And this radiation level is more than 500 times than background, but it is still about 50 microsieverts. And this Radiacode 0 has a range of 9 million microsieverts. So as you can see, with this everyday object we just cannot reach this limit dose. This Radiacode 0 was designed for extreme conditions, which can be an interesting R&D work for Radiacode team. Practically on my own I don't see a reason to buy it. Of course it will work for these objects as well, but just keep in mind that it has a less sensitivity. Its sensitivity is lower compared to all other Radiacode models, and it also cannot show the gamma spectrum, which is a cool feature, and I will show it later in this video. And now let's switch to the real devices I have. I will show Radiacode 1110 and Radiacode 103G. And as a first step I will start with the unboxing. This is the Radiacode 1110 I bought. As I mentioned before, this video is not sponsored and I bought it on my own. As we can see, it is a relatively small box. We have a short manual. Radiacode communicates with the phone using Bluetooth Low Energy. You can also connect it via USB to the computer. You can also use USB for charging. And by the way, some people asked why Radiacode cannot send clicks directly to the Bluetooth headphones. Their answer is easy. Bluetooth Low Energy and Bluetooth Audio are completely different protocols. Bluetooth Low Energy is designed to send only small chunks of data, but not audio. This is 103G for the comparison. Visually it looks the same, maybe it's only a bit smaller, like 1 mm. Let's now turn it on. I also connected the Radiacode to the app. And funny enough, I see the red LED, which means high radiation level, and apparently the counts per second threshold is set for the previous model. I need to change it in the settings. Radiacode app is good and functional. It has a lot of settings and lots of features. I can also disable or enable particle clicks. And now both devices are running and we can see the first difference. The counts per second rate is higher for the newest model. It's more sensitive. I think the newer model is slightly bigger, but it's still portable, which is nice. It easily fits in the pocket. The device itself has only 3 buttons, a menu button and 2 buttons up and down. You can open the menu and you can switch between modes, like counts per second, so microsieverts per hour, or search mode, and so on. For example, I can switch to search mode and use this watch with the Radium Dial. And as we can see, the graph values are almost immediately increasing. It is also useful if you want to compare the level with background radiation. And now let's compare the sensitivity. As a first test I will use this Chinese pendant with the thorium glass. And first I'm using the Radiacode 110. And as we can see, alarm starts almost immediately. As an aside note, this alarm means that the level is higher than normal, but it doesn't mean that it's really dangerous. This radiation level is practically equal to the radiation during the flight because of the cosmic rays. So when you're traveling the airplane, you get the same radiation level for 2-3 hours and nobody's complaining. I also switched both devices to the CPS mode, which means counts per second. I think in this mode the screen values are refreshing faster, so it's easier to see. And it's really hard to tell, but the Radiacode 110 indeed looks faster. It's reacting faster to a higher dose. This is not a drastic difference because 10 counts per second is also a good value. So when we put the radioactive source, we see the increase almost immediately in both devices. So the Radiacode 110 looks faster, but 103G also works well, especially when the radiation dose is high, both devices reacting practically immediately. And here is the Jazz clock, for example. Both devices work well, but generally speaking, every detector can find the strong radioactive source, and it is much more challenging to find the weak one. Uranium glass is not so radioactive. Let's test both radiocodes with it. This is the uranium glass plate made in Holland. It also nicely glows in the UV light, and it is slightly radioactive. And now I'm putting both devices on the plate. And yes, it is clearly visible that the new Radiacode is much faster with the weak source. As we can see, for both devices, the counts per second value is about 2 times higher on the uranium glass plate, but the Radiacode 110 displayed the new value much faster. So as we can see, it is a good improvement. And by the way, if you want to detect if the object is radioactive or not, in my opinion, CPS mode is the fastest. In the microsieverts per hour mode, the increase may be lower or it can get more time. But even in the microsieverts per hour mode, a new Radiacode 10 reacts fast, as we can see. And last but not least, I can show the search mode, where the Radiacode displays the graph. I rarely use this mode myself. On the small screen it is just easier to read the CPS numbers, but still, if you want to use it, it is doable. And on the graph we can also see the radiation increase as well, so it works. And now let's compare the gamma spectrum on both devices. Gamma spectroscopy is a very cool feature of all Radiacode devices except 0. And the general idea is simple. Every radioactive isotope emits gamma rays of the specific energies. Gamma rays are actually photons, so practically you can think about it like about colors. So it's like the radioactive object really glows in the dark, but with an invisible color in the far part of the spectrum. And the scintillation detector can get this energy and we can see it on the spectrum. And practically every isotope has a unique combination of peaks. So by observing the peaks we can figure out what object it is even without touching it, which is cool. And let's see how it works. And as the first example, I have this Chinese pendant. It was sold as ionizing healing pendant, but it was not written that it is radioactive. Technically we don't know which element is it. So I will use 2 Radiacode devices to collect the spectrum for several hours. First I need to press restart accumulation and the collection will be started. The cool thing is that the Radiacode is collecting the spectrum in its own memory, so it's fully autonomous. I can just keep it running, return later and see the result. I collected the spectrum for several hours, but with the magic of the video you will see it right now. And the result is especially interesting for 103G, because this device is specially intended for spectrometry. It can provide a higher spectral resolution. Let's see how it works. And as we can see, the result is interesting. First, we can easily detect that the peaks belong to thorium, so this is a radioactive decay of thorium. So we know that this pendant contains thorium glass. And the second, about the peaks quality. As we can see, both devices works good. And indeed, for 103G, peaks are a bit more sharp. They are easy to detect. Is it a drastic difference? It depends on what you need. As we can see, for both devices we can easily detect that it is thorium, it's not a problem. But maybe if you are really interested in minerals or in chemistry and you have a special lead crystal where you can get a spectrum with a high resolution, this difference may be more significant. In my opinion, for generic use cases, both devices are good enough. And let's do a second experiment. In this example I have a mineral and let's say I want to know what is it. The same way as with pendant, I will collect the spectrum for several hours. And here is the result. And as we can see, the spectrum is completely different comparing to thorium. And here we can see the peaks belongs to radium. Why radium? We can open the Wikipedia and see that the radium is a part of the radioactive decay of uranium. So it's really interesting to see how the radioactive decay works. It's the nuclear physics on our desk. And as for the comparison, 103G indeed has a bit higher resolution. We can see that peaks are more sharp, the resolution is a bit higher. Again, if it's crucial for you or not, you can decide on your own. As for the comparison like this, we can see that both detectors allows us to figure out is it thorium or uranium. And now let's answer the next question. We know that the bananas are radioactive. Can we see it on the spectrum? And indeed we can. Bananas are naturally radioactive because they contain a bit amount of potassium. However, the amount of potassium in each banana is too small. Instead, I cheated a bit and I just bought the potassium in the supermarket. It is slightly radioactive and I can verify it with the Geiger counter. We can see that the radiation level is higher than the background. However, the Geiger counter cannot tell us why the object is radioactive. And now I will put both Radiacode devices and I will collect the spectrum for the whole night. This radiation source is weak, so the longer the collection time the better, and here is the result. And as we can see, there is a clearly visible peak, and now you can see the both spectra on the screen. We can see that 103G indeed provides a bit better resolution. However, on both spectra we can see the peak, and we can see that it belongs to the potassium 40. Ideally, this experiment should be made in the lead castle, so there is no background radiation, but you can still get the idea. And now let's make a short summary. If you want to have a radiation detector, which Radiacode model should you buy and do you need it at all? And as we can see, there are many parameters to consider, so it's not so easy, but I think I can give a good advice. First, if you just want a radiation detector to check the vintage clock or the uranium glass, you don't need Radiacode at all. You can easily buy a Geiger counter for less than $100 and it will work well for this task. You just don't need to spend too much money for that. I personally like GMC models. They are functional, cheap and reliable, and it is not sponsored, it's just my opinion. But if you have more interest in science, Radiacode are fantastic devices, and as we can see, they have a lot of features. It will even take some time to learn how it works, but this is a part of the fun, right? So which model should you choose? As we can see, at the moment of making this video, Radiacode 110 is the best general purpose device. It has the highest sensitivity and it works well. Radiacode 103G has a better spectral resolution. However, it's much more expensive, and as we can see, the real difference is not that big. So you should choose it only if you are specifically interested in getting different spectra and you are serious in that. If your budget is strictly limited, previous models are also good. For example, Radiacode 103 has a less sensitivity compared to 110. However, it will have the same functionality in general. The real difference here is like between iPhone 10 and iPhone 11. The newest model is slightly better, slightly faster and so on. However, it's not a game changer, and all the things you can do with Radiacode 110 you can also do with Radiacode 103. As for the Radiacode 0, it is a niche device specially designed for the very high doses. It will work for the normal doses as well, but it has less sensitivity and it cannot get gamma spectrum. So personally I don't need it and I don't want to buy it, but it's up to you if you want it or not. And as I mentioned in the beginning of this video, I love Radiacode devices. However, there is one disadvantage that I want to mention, and this is a low sensitivity for beta. And to show this I will do a fun experiment. Here I have a small jar covered with the uranium glaze, and this jar is a strong beta emitter. And this is my DIY radiation detector that I did with the cheap SBM-20 Geiger Mueller tube. And I placed this jar about 40 centimeters from the detector, and the levels are already 2 times higher than the background. And in the same condition, Radiacode just detects nothing, and I need to put it directly on the surface to see reliable readings. Beta radiation can travel surprisingly far in the air, but if the Radiacode is only device you have, you just don't know it. As we can see, formally on paper, Radiacode works and it can detect that this object is radioactive, but there is enough room for improvement. and hopefully in the future the Radiacode team will make a new device with better sensors, or maybe with 2 different sensors. But at least for now, if you are serious in measuring the radiation, the best way is to just have 2 devices from different manufacturers. And that's it for this video. Thanks for watching. I hope you learned something new. If you want me to do other tests, don't hesitate to write in the comments below and maybe I will make a separate video. Press like and subscribe and hit the notification bell if you enjoyed this video and you don't want to miss the next one. You are also welcome to visit my Patreon page. This support allows me to buy things like this for testing. Thanks for watching and see you next time.